Hey guys, welcome back to your design school, and today is day 7. I can't believe that it has been a week, and hope you are enjoying the software and learning something out of it. So if you are new to this channel, just pause the video here itself and go check those previous videos. Make sure you follow the sequence. That will be easy for you to understand how we have came so far. You might have observed that suddenly my wallpaper changed. How this happened? Okay, so even I was sick of that Lamborghini Aventador for past couple of days, so I plan to change my wallpapers so that even you can feel good after watching different cars every single day. And I'll be sharing you some specs of the cars so you'll gain some knowledge along the side. I'll just hide the desktop icon so that you can see the car how it looks. Whoa, so this is a Rimac Concept S 2014 model, and for those who don't know what are the specs of it, it has 1224 horsepower and 1600 newton meter of torque. Yeah, you heard it right. And it can do 0 to 100 in just 2.5 seconds. Okay, and by the time I told you all the specs, this could have already reached its top speed of 340 kilometers per hour. Yeah, guys, you are hearing it right. And this isn't the latest model of them. Let me just go to the Chrome and let me show you what is the successor of Concept S. Let me just go to the Google Chrome. They have something called Concept 2, and they have revealed it today itself, and they changed its name a little bit. Oh, this is not that Concept 2. We'll just put Rimac in front of that, just like that, and here it comes. Whoa, stunning looking car, right? It has those butterfly doors. Really awesome looking car. Okay, so this has the upgraded powertrain and battery. It has 120 kilowatt hours of battery pack with quad motors, individual motors on each wheel, and this thing puts out 1914 horsepower and 2300 newton meters of torque, and can do 0 to 100 in just 1.85 seconds. You won't even believe, right? Here's the Roadster. It claimed that it can do 1.9 seconds, but still it has not been revealed yet. Anyways, we'll get back to our topic. Okay, if you want, I can continue this for whole day about cars or in general the automotive industry. So if you want to hear more about it, just comment below. I would like to hear from you whether you are interested in podcast or something like that. I'll do that for you as well. Anyways, we'll get started. So what I have planned today is actually I hadn't planned anything, so I was just cleaning my wardrobe and I found my old book from diploma. In diploma I had a subject called Pro E, that is Pro Engineer. So I was just going through that book where I found out some really good sketches for beginners like you where you can learn out of it. So those are mostly automobile parts, as you can see here some of the sketches. Yeah, I used to be good at drawing at that time, I guess. Anyways, so this is the part. This is the piston. For those who don't know what the piston is, just go and Google Chrome it. Or else if I start explaining what piston is, it will take another half an hour or 1 hour, I guess. Or else I'll mention it in some other video. I'll make a particular video for the engine parts. Anyways, we'll get started with this. As you can see, this is what I had drawn, and you can see here the professor has given me 9 out of 10. I don't know why I had done such a nice sketch. As you can see, but they have that habit, Even you might have experienced that professors have a habit that they reduce marks, they never gave it full out of full, as if they are giving money out of their pocket. But anyways, we'll start making this sketch. Okay, so as you can see, this is a 2D version. Whatever you see that it has been hatched, it is a cross section, it is a cross sectional view. So we'll get started. Just go and open up your Fusion 360 software. In that, what you have to do is go select sketch and select the right plane. That is what we are going to sketch on. Okay, so as you can see, the piston is the piston center. Okay, so from there we have to start making the whole diagram. Okay, just take a snap of your screen, or else I have even provided the link of this image in the description. You can download it from there also. So we'll start with the center here. As you can see, the dimensions are given on the right hand side and some of them are also given on the left hand side. So the total length of the piston, or else you can call it height, it is 130 mm. Okay, so what we have to do is we'll make it half of 130. This height will be half of 130. Okay, so just go here, select line, make it 130 by 2. It became little slant. Just select this, press it there, make sure it is 130 by 2. 5. Then go back to sketch, and the line we made has to be construction since we are not going to extrude that. Okay, then the diameter of the piston, as you can see, it is mentioned this side, it is 92 mm. So we'll just wait. The diameter of the piston is 92, so we have to convert it to radius. We just have to divide it by 2 because we are making only the symmetrical part of the piston. So we'll just make the mirror half of this piston. Just minimize and use again line. This time make it 92 divided by 2, hit enter. And we'll make this as construction as I told you. Okay, now we'll continue this, make it same, make it construction, 65, enter. Then we'll start making these edges. Okay, so don't worry that there are 3 different sketches. These are like, this is the front view of the piston, this is how it looks, this is the right hand side view, and this is the top view. That is how they define in the 2D sketch, so that all dimensions are easily visible and available right in front of you. Okay, as you can see, now we have to drop the piston from here for 12 mm. see here. Again is flying. Turn off the construction. 12. Enter. Now we have to continue with this pattern. So that is 6 mm in depth and 3 mm wide. Here the dimensions are given. So like that we have to make 3 cutouts where the rings will fit. If you don't know, piston has its own rings. 2 are oil rings and 1 is compression ring. Just for sealing purpose they use that. There will be clearance in piston and the cylinder, not too much, but still it will be there. Just to seal that little distance they use the piston rings. So that's 3, this will be 6. Continue that. As most of the piston has 3 rings, as I told you, we'll be making 3 cutouts in the piston where our piston rings will fit. So I've made that. It is looking completely messed up due to this all dimensions. If you want it to look clean, just go here. As you can see here, show dimensions is on. Just turn that off and now it looks clean, right? Go back to our sketch. Now this part is completed. This one. Then we don't know how much this part is, how much this has been extruded outside. So for that, what we have to do is here the given dimension. The lower part of the piston is called as piston skirt. I don't know why do they call it, because it looks like skirt, I guess. So that dimension they have given as 96 mm, and the upper one we already know it is 92. So if you subtract 96 from 92, it's 4 mm, and divide it by 2 because we are making only the mirror half part. So that will be 2. 4 divided by 2 to get right. So we'll extrude. Now you have to go 8 mm down, but we don't know this distance. Okay, this distance we don't know, but we know that this line is as you can see, this line connects straight to this one, so we'll use the reference of that. So what we have to do is use line, click here, then don't click anywhere, just go. You'll see it will automatically try to connect there. Don't click there, just drag it down, it will make a reference line. Okay. And click where the reference line gets perpendicular, like that. Then we'll go 8 mm down. Then now do the same. This part is completed. Now we have to make this. We don't know dimension of this, but we know that it is the distance from center to the bottommost part. It is 66 mm. It is mentioned here, and this distance is 8, so half of it is 4. 4 minus 66 will get 62. Then use line, make that as 62. Right there. Now we'll make this part. Use line, make it 6 mm wide and 6 mm in height. Again, we don't know this dimension, so we'll just leave it there. I'll tell you how to do that later on. Till then, we'll make the thickness of the piston. As you can see here, the piston has varying thickness all over its body. On the top it is around 8 mm thick, whereas on the sides it is slightly less, like 4 mm or 5 mm thick, because the most of the time the impact will be from the top of the piston, where it is called as piston head. So that's why they use more material at the head. So we know that it is 8 mm thick on top and of radius 78 mm. Diameter is 78, so we'll just make half of that. Use line, make this as 8, enter. Then half of 72, oh sorry, it is 78. Just do some corrections over there. Make 878, just like that. Till here our piston is ready. Now again they have not mentioned from this to this point what is the distance, so I'll again just guess it. You don't need any rocket science knowledge, or you don't have to be a scholar to find this dimension. It is very easy. I'll show you how to do that. We know that the total length of or height of the piston is 130, and from here to this point it is mentioned as 50, and the thickness of the head is 8 mm. So what we'll just do is subtract 8 from 130, we'll get as 122. Then we'll subtract 150 from 120, so we'll make that. Select line, make that as 122, 50. Perfect. Now here this distance they have mentioned as 88 mm. It is the diameter, so again we'll divide it by 2, so it will be 44. And this they have mentioned as 84, so that will be 42. 44 minus 42, you'll get it as 2 mm. So from here it goes inside 2 mm. Okay, again they have not mentioned this distance, so it is 50 minus 6, it is 54. Go to line again, make it 54. As you can see here, this line isn't perpendicular or 90 degree to this line, it has slightly angle. So for that what we'll do is, this distance they have mentioned it as 86, so we'll make half of it. So what you just have to do is go here, create, you'll find sketch dimension, use that tool, select this small little circle, then this center line. It will show up some dimensions. We know that it is 86, we'll make half of it, so type 86 by 2. This whole thing came forward, so we don't want that to happen. So what's the other thing we can do? We'll just delete this line. Okay, then we'll use line construction. There are multiple ways, that's why I keep telling. Okay, then we'll go here, and make it 86 by 2. select line, make it construction, then type 42, hit enter, let that line be construction, then we'll make it 86 by 2. Don't click here, just take the reference of this and make it 86 by 2, hit enter. As you can see now, this is the gap that we were looking for. Then delete this line, turn off the construction, go back to line and just connect it. Oof, finally. Then fill up this gap too. As you can see, we are almost there. That is how our sketch looks like, right? Just check whether there are some extra lines or something, just trim it out. If everything looks good, just finish the sketch. So that is what we have made so far. Just select this plane now, whatever we have made so far. Use the tool called revolve, then select this blue line, center axis. Oh, finally our hard work paid off, right? Our piston is here. This isn't ready, still there's a lot more to go. Hit OK. So these are the 3 grooves that I was talking about, first, second and third. This is where our rings will sit, 1 compression and 2 oil rings. As I told you before, this is the piston head. Okay, what else we are left with? Here, as you can see, there's a small fillet there, 6 mm radius. We'll do that too. That won't matter anyway, but we'll still make that. Select that circle, then go to fillet or just hit fillet F and make it 6. Nice curve you get there, then hit OK. Almost over. Okay, so if you don't know, this piston is connected to the crankshaft via a connecting rod. Let me show you how it looks. Piston. Go to images. This is how it looks. This is a modern type of piston and slightly complicated, so this is our piston. This is what it's gonna look like If you observe, every single piston has a hole at its center. So if you don't know what that is for, let me show you. Yeah, here it is visible. So this piston is connected to this connecting rod, and further this rotates the crankshaft. So for connecting this piston to this connecting rod, they use a piston pin. That is what they call it. Here it is there. Piston pin, wrist pin, whatever you call it. This is the connecting rod. This is the bigger end and this is the smaller end of the connecting rod. So for that we have to make this hole in the piston. So we'll make that. We know that hole is of 24 mm diameter. See the dimension they have given it here. So from this point to this point, the diameter of that hole is 24 mm. Okay. So we'll go back to sketch. And we'll select our right plane. And if you want, you can even hide the bodies, so it will be easy for you to construct. Use circle. Make that as 24 mm in diameter. Finish the sketch. Turn on the bodies. Again, turn off the body. Select the plane that we made just now and use extrude. Change the direction to symmetric and make that as, you know, the diameter is 92, so we'll extend it a little further. We'll make that as 100. Not 1000, 100. Okay. And operation, we want to cut that much part out, so we'll use cut. Again, turn on the bodies. As you can see here, that cut is taking place right there. Hit OK, and we have created a groove where we can slide our piston pin. That is what it looks like. Okay. Now there has to be some extrusion where the connecting rod will come and sit, and there will be short clearance in between the piston and the connecting rod. As you can see here, we can't directly insert the connecting rod inside this piston. It will wobble here and there, so we want to limit and restrict it from sliding here and there. So for that we have to extend the piston slightly from both the sides, so that the connecting rod should go easily and fit there. Let me show you if it is. Yeah, right. It is, yeah, as you can see. The piston is extruded a little bit inside, as you can see, where just a little bit clearances is provided for the connecting rod to sit inside this piston. So we'll make this part now. So for that, what we have to do is we have to make it of 36 mm diameter, and that has to be thorough. So we have to cut 24 mm diameter from its center. So we'll make that. So as you know, making sketch here is way too much complicated. So what I have planned, we'll just make a cylindrical shape of 36 mm diameter, outer diameter and inner diameter of 24 mm, and we'll start with the center and we'll extrude it symmetrically till it touches the inner part of the piston, and we'll just trim it out the center part. So that will be easy. Let me show you what I'm saying. We'll go back to the right plane. We'll just turn off the bodies, but we want the origin to be there, right? And also the grids. Again, use circle. Make two circles of 36 mm and 24 mm diameters. One should be 36, not 6. I said 36. And another of 24. Right? Finish the sketch. Tilt that a little bit. Now select this outer portion, outer part of the circle, and again use extrude. Make sure it is symmetric. So for the length, we have to make it of 78 mm in diameter, or we can even make it as 80, slightly inside. That won't cause any problem. So we'll make that as 80. We'll turn on the bodies. Now this became 80 mm, but if you see, when you use the direction as symmetric, what it does, it elongates 80 mm on each side. We want the total length to be 80, so what we'll do is just make that as 80 by 2, and this time we want it to join, not to cut. Okay, just like that. There's still little bit gap is there. You can fill that, make that as 82 by 2. It is there, make that as 85. Now it collides with that, the part of the piston. but it is coming out from this side, so we don't want that. Again, make that as 83. Yeah, 83 is perfect. Hit OK. Now we'll check. Looks perfect, right? Now we just have to cut here so that our connecting rod could be inserted in the piston. So for that, again, you have to select the right plane. Again, make a circle of 36 mm diameter. Finish the sketch, select that circle, tilt it a little bit. Okay, but we don't know how much we have to cut. So for that, we'll go into the sketch. Okay, that is 54 mm. We want that cut to be 54 mm. Okay, since we are using the direction as symmetric, we'll make the distance as 54 divided by 2. Perfect. Let the operation be cut. Hit OK. And there it is. That's where your connecting rod is going to fit. Not as difficult as it looks, right? So what else we are left with? Almost everything is over, I guess, right? Everything is over. So just for weight saving, sometimes what they do is they remove some material from the piston head. So we'll do the same. Select the piston head, then go back to sketch and use circle. Make that as 75 mm in diameter. Hit enter. Now select that circle. Finish the sketch, then use extrude, make it as negative 3 mm, or else we'll make it as negative 4. Hit enter, and this will make it little chamfer. So for that, go here, select the tool called chamfer and make that as 2. 4 is perfect. Hit OK. So we have saved a little bit to weight from the piston head. Now the piston has become a little lighter in weight, but make sure you don't remove too much material or else the piston head will get slightly weak and might fail while it is in working condition. So that's how our piston looks like. Hope you learned how you can make a piston. That's way too easy. Keep practicing this. Once you make with watching how I did, try it once again without looking at the video. Just keep the dimensions in front of you and the 2D sketch and try making it once again. If you face any problem, just put them down in the comments. I'll surely reply you. And if there are any parts that you want to learn, just you can type those also in comments. I'll try making those also. Okay, till then, next time, stay tuned and keep practicing. Thank you.